Have you ever noticed how cutting holes in things can lead to very curious results? Picture this: you have two perfectly round balls. One is as tiny as a marble, and the other is as ginormous as a planet. Now, imagine you drill a straight, round tunnel all the way through the centers of both spheres. When you're done, there's a ring-shaped piece left over, like the band of a napkin ring. Here's the twist: if you make sure that the rings cut out of both spheres are the exact same height from top to bottom, then, no matter how big or small the sphere was, both leftover rings will have the same volume. At first, this sounds impossible. How can a napkin ring from a marble and a ring from a planet be the same size? This is why scientists call it the Napkin Ring Paradox. Let's look more closely. We need to keep track of three measurements. R, the original sphere's radius, the distance from its center to its surface. R, the radius of the hole we're drilling straight through the middle. H, the height of the ring-shaped leftover piece. You might think that the larger the sphere, the bigger the ring. But something very clever happens. When you use math to find the volume, how much space is inside the ring, you discover that the answer doesn't depend at all on the size of the sphere. Instead, it only depends on the height of the leftover ring. The crazy cool formula is V equals pi times h cubed, 6. That's it. No R. No R. Just the height. How can this be? Let's peel it apart. Imagine you look at the ring from the side and slice it into super thin pancakes. At each pancake's height, there's a hole in the middle. The outer edge of each pancake matches the outside of the sphere, while the inner edge is the cylinder we drilled out. The area of each pancake looks like a donut. As the sphere grows, the hole in the middle grows too. When the donuts are stacked high enough to keep the height unchanged, the extra donut is exactly filled by the bigger hole. The increase in sphere size is cancelled by the wider tunnel. This is not magic, it's a wonderful moment when our imagination and math meet. The napkin ring paradox reminds us that math can be full of surprises, helping us see that sometimes, the most obvious answer isn't always the correct one. So, next time you see a napkin ring, remember, there might be more to it than meets the eye.